In this numerical, two capacitors C1 and C2 are connected in series across a 120 volt supply, right? So the capacitances of C1 and C2 are 6 microfarad and 4 microfarad, right? Now we need to calculate the potential difference across each capacitor and energy stored in each capacitor. So when two capacitors are connected in series, then the equivalent capacitance is given by the formula 1 by C equal to 1 by C1 plus 1 by C2. So C can be equivalent capacitance can be calculated in this way as 2.4 microfarad. Okay, it's given that the potential difference, that is the connected power source, is 120 volt. So the charge on equivalent capacitance, that is calculated by the formula Q equal to CV. So Q, the charge, is calculated as equivalent capacitance value, that is 2.4 microfarad, which we have calculated, into 120 volt, right? This will give you the value of Q as a 24 into 12 microcoulomb, which will be 240 plus 48, that is 288. Yeah, so 288 microcoulomb. So this charge will be the charge on individual capacitors also, that is on capacitor 1 and capacitor 2, C1 and C2. So to calculate the potential difference across C1, right, that is, since we know the formula Q equal to CV, so we can write V1, that is a potential difference across capacitor 1, is equal to Q by C1, right, this one. So the V1 can be calculated, that is potential difference across capacitor 1 is calculated by 288 microcoulomb divided by 4 microfarad. This will be coming as 72 volt. Similarly, potential difference across C2 is calculated as Q by C2. So Q is the 288 microcoulomb, which we have calculated, divided by 6 microfarad. This will give you 48 volt. Now the energy stored on a capacitor is given by the formula half CV square. So energy stored on C1 equal to 1 by 2 into C1 into V1 square, where C1 and V1 are the values of capacitor 1 and potential difference across capacitor 1. So putting up the value, just calculate it. It will be 2 into 72 square into 10 to the power minus 6, that is joule. Similarly, energy stored on C2 will be half CV square, where C2 and V2 will be placed. So it will be coming as 3 into 48 square joule, right? This is simple arithmetic calculation. You can calculate it and you will be having your answers. Thank you for watching.